Okay, so this is our problem that we're solving today. It's special factorization rules. If you forget the special factorization rules, just Google special factoring. This is the third hit on Google or something. I'll put this link in the comments, but these are pretty useful formulas. So you're going to want to have these on hand. Okay, so let's get back to this question. So I know this doesn't look like the special factoring. We see squareds here and 2ab, and there's a squared, b squared here. But essentially, it's the same thing, right? We're going to try to fit this into this formula. So how do we do it? Well, when we had something like 25a squared minus, so okay, let's see if this was 25a squared. How do we get to this a? Well, you take the square root of both of these, and you say, well, our a value is the square root of a and the square root of 25. So our a value would be 5a, right? So essentially, we're doing the same thing. We're going to ask, what value is this to the fourth? So we think we're suspicious that something to the fourth power is 1296, and something to the fourth power is 625. Okay, so that's our first thing. So what can we rewrite those as? I don't know off the top of my head, but we can always guess and check with a calculator. Let's say 5 times 5 times 5 times 5 equals 625. Oh, hey, I just pulled 5 out of thin air. I just guessed. I said, what is 5 to the fourth? And it just happened to be 625. I got lucky there. So we already know this. So we can already start rewriting plus b to the fourth, 5 to the fourth. Okay? So let's pull up the calculator again. So we know something larger is 1296. So maybe I'll try 7 times 7 times 7 times 7. Well, that's too big. So actually it's probably 6 because that's between 5 and 7. So 6 times 6 times 6 times 6 equals 1296. Perfect. Okay. So we've got 6 to the fourth, right? That's what I just found. A to the fourth equals or minus 1800. And actually, let's start rewriting it like this. So that's 2 times 900 a squared b squared. Okay, so again, just like if we had 25a squared, you would write in this parentheses, you would write 5a. We're going to just work with these. So what would we write in the parentheses to get? So we want something squared to equal 6 to the fourth, a to the fourth. Right? I know this is looking difficult, but we want to get it looking like this. So we want to rewrite this with a square around it. So again, that's actually 6 to the 2. Right? Just use your exponent rules, a to the 2. And you can check it, right? Because if you did your exponent rules, you'd kind of distribute that too, so you'd have 6 to the 4, a to the 4. Okay, and again, this problem they gave you special, and it just happens that everything's perfectly square. They wouldn't give you a problem with like decimals and gross factors. But we can rewrite this. This is the same as this. So let's start rewriting this whole thing. Okay, and then we'll keep this how it is. And then we want to rewrite this the same way. So plus 5 squared b squared squared. Okay, and that equals, a plus b squared. But kind of, right? So it actually, we're looking and we see this rule is something squared. So this is kind of our whole a. So let's just replace that here, right? We have this looking exactly like this, right? We have this, and actually let's break down this 900. So I would argue that 900 is a times b, right? So it's 36 times 25. So 36 times 25. So let's look at what that is, make sure that's right. 36 times 25, right, 900. Okay. So now we have it exactly like this, except with some square terms. So we've rewritten this with different numbers so that we can have exactly this rule going on. So our A is actually this. So let's replace that A. And our B is this. So let's replace the B. And we can rewrite this as 36 if we want. 36 and 25. Okay. So this is how we factor it. And we've just used this rule to factor this. And again, we can check. And actually, I was going to say we could check if we could factor this anymore. Let's look at our special factorization rules. Where was that? Okay. And there's actually a special factorization for a squared minus b squared, but not a squared plus b squared. You could just expand it, right? So if we got an a squared minus b squared, we could break it up into this, but we can't do it. So that should be our final answer. And again, we treated it a little different. We knew that there was a fourth power here, and we said how can we put this in this box, right? What squared equals 6 to the 4, a to the 4, and it's 6 squared, a squared. And you can plug it into the formula. So I hope this helps. Please email me if this is still confusing. I'd be happy to help a little more.